Hi everyone, we're going to talk about quantum mechanics, kind of exciting. We're going to look at the magnetic quantum number. This is from the Jee Main exam, August 31st, 9 a.m. Question number 2, magnetic quantum number. Let's see what it says. In germanium that has 32 protons, how many completely filled orbitals are there which have an m sub l of 0? An m sub l of 0. Okay, really quick background for you. There are 4 quantum numbers, and every electron has a unique set of 4 quantum numbers. First, you have the principal quantum number n. That's going to be the energy level. Next, L is called the angular momentum quantum number, and that's really just subshells. You have 4 subshells, S, P, D, and F, and we just number those. 0 for S, 1 P, 2 D, 3 F. Notice right here, the angular momentum, the L, is always going to be at least 1 less than n. So for example, if I had an energy level 2, then that means L could be 1 or 0. 1 or 0. Nice. Our magnetic quantum number, and that's our focus for today, this is really the orbitals, and the m sub L is going to be plus or minus L. So go back to my example. If I have energy level 2, that means my L could be 1 or 0, and so my m sub L is going to be 1, 0, and minus 1. It's from negative L to positive L. And then m sub s is just our electron spin quantum number, and that's if the electron is going to spin up or down inside the orbital, and we write that as a plus or a minus 1/2. Nice. So let's write the electron configuration for our germanium, and then notice I attached it to orbital notation. Now I'm going to attach videos for quantum mechanics, a video for electron configuration and orbital notation if you need review on that. So here's our germanium. We're going to have a 1s2, there's your 2 electrons, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. Now, underneath the orbitals, we can label them with the magnetic quantum number. Every single one of these lines represents an orbital, and you can fit a maximum of 2 electrons in an orbital. The orbitals are given a label. So when we're at the first energy level, that would be n equals 1. The s block, that would be L equals 0. We have 1 orbital, and that orbital is 0. That orbital is 0. Same thing with the 2s is going to be a 0. A little note here, come back here with me. If energy level is 1, the L n minus 1 is going to be 0. 1 minus 1 will be 0. And then the m sub L is plus or minus L. Well, if L is 0, then we're going to have plus or minus 0, which is just 0. There it is. There you see it. There's your 0. This is how this all comes together. We're trying to give an address for those electrons, and here's the way we do it with those 4 numbers. Now look at the P. So for our energy level 2, that P block, a P can have 3, ready for this? It can have 3 orbitals. It's going to be minus 1, 0, and plus 1. So our P block right there, the L is 1, which means m sub L will be plus or minus 1. Minus 1, 0, plus 1. Nice. I know the connections are starting to be made here. Your S is 0. Again, here's your P. The P is 1, so that means we're going to have m sub L plus or minus 1. Minus 1, 0, plus 1. There's your S is 0. Ooh, look at our D. So our D subshell, it's 2. So m sub L will be plus or minus 2. Minus 2, minus 1, 0, plus 1, plus 2. Nice. And then over here, we have our P, minus 1, 0, plus 1. Now look carefully at this question. It wants to know how many completely filled orbitals, and it wants m sub L equals 0. So let's look at our zeros. Here's filled, there's 0, 0, so let's count 1, 2, 3, 4, 5. I'm just looking at those 2 arrows. 6, 7, and we don't count this one. Why don't we count that last one? Because it's not filled. It's not filled. It only has 1 electron in it, not 2. So we take that off. So total, there are going to be 7 orbitals, m sub L, that magnetic quantum number, 7 orbitals that are an m sub L of 0 and have the electron spinning up, the electron spinning down. They're filled. Nice. If you need some more help with this, please go to those links up above and you can watch some additional videos. Thanks so much. Take care. Good luck with your test.